In this video, we'll generate the decaying cosine, which is e to the minus vx cosine wx, where the value of v is data validation, list of items, that's 0.4 up to 1, so 0.4, 0.5, and 1. And we can start from 1. Likewise, the value w, which is data validation, list of items, from 1, 2, and 2.5. So 1, 2, and 2.5. We can also start from 1. These values will be used in cosine, and we'll copy the same. We will use it on the expansion, so Control V. You can start from 1 and also 1. The color will be red. Now the dataset. So RA formula, exponent minus V times X. So minus V times X. That's the first part. The second part. The second part is cosine Wx. So cosine W times X. Likewise, the expansion, which is the summation of a times x to the power n, where the value of n is from 0 to infinity. You can start from 0 up to infinity. 17 is good enough. Now the value of the expansion, which is equal to RA formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1. And the coefficient a will be this range. If you want to know how this is calculated, post your email address in the comments section below, and I'll share you the complete version of this video. Now we chart this. Insert chart. And we use scatter chart. And show the trend line. That's polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. We don't need a title, so we'll delete this. And here's our trend line and polynomial of the decaying cosine and its expansion. Let's compare the coefficients. So coefficient of x to the 0, 1. Coefficient of x, negative 1. Coefficient of x squared, 5.01 times 10 to the minus 4. Coefficient of x cubed, 0.335. This is 0.335. Coefficient of x to the 4th, 0.17. 0.17. Coefficient of x to the 5th, 0.0375. Coefficient of x cubed, 3 times 10 to the minus 3. And coefficient of x to the 7, 2.54 times 10 to the minus 4. Coefficient of x to the 8, 4.99 times 10 to the minus 5. Suppose I change this to 2. I will have to change the expansion to 2. Change this to 0.4. I'll change the expansion also to 0.4. I'll change this to 2.5. I'll change this also to 2.5. Change this to 1. I can change this also to 1. If you need the formula of column A or the coefficient. Post your email address on the comment section below, and I'll share you the private video showing the complete solution. This completes the use of Taylor Maclaurin series sum and LINEST polynomial regression to generate the decaying cosine function.